Hi guys, in today's video we're going to be learning how to calculate the equation of a straight line. Now before getting started with this, it's really important that you already have a bit of a grounding in a couple of different areas. So first of all, you should be really familiar with how to label points on a graph. So you should know that we always do the x coordinate followed by the y coordinate. It's also really important that you know how to calculate the gradient of a straight line, because that is going to be essential to working out the equation of the straight line. So if you don't know how to do that, then first of all go back and watch the video about calculating the gradient of a straight line. However, if you're comfortable with both of those, then let's get cracking with calculating the equation of a straight line. So, the equation of a straight line basically describes the relationship between the x-axis and the y-axis. So the equation for all straight lines is written as y equals mx plus c. Now you should know already from your work on gradient that m here basically just means the steepness of the line, or the gradient of the line. And we already know how to work that out. As long as we have two coordinates, we should be able to work out the gradient of a straight line quite easily. We know that x is just going to be an x value and y is going to be a y value. And the question is, well, what is c? That's something that we haven't figured out yet, and we'll be able to solve that later. But what c tells us, or what c is supposed to tell us, is where the line crosses the y-axis. Okay? So that's what c is supposed to tell us. So everything about this straight line can be described using this equation, y equals mx plus c. Now to actually find the equation, we're going to need to solve some of the values first. And we're going to start off with working out the gradient of the straight line. So just like before, we're going to label these points, point 2 and point 1. So we've got coordinate 1 and coordinate 2. And we know that we have the x and the y values of each of them here. So we've got x and y for coordinate 1 and 2. And we're going to start off solving the gradient. So m equals y2, well that's going to be 9, minus y1, which is going to be 4, divided by x2, which is 7, and x1, which is 2. So the gradient of this straight line is 9 minus 4 divided by 7 minus 2, so that's 5 divided by 5, so m equals 1. This is just a gradient of 1. Now, because we now know the gradient, it's just 1 in this case, we can now treat this like any other algebra problem to find out what c is. Let's see how that works. I'm going to change colours just now. And we know that y equals 1x plus c. So y equals 1x plus c. Well, again, there's a lot of letters in there and not a lot of numbers. However, we know that we can put in an x value and a y value by stealing the information from any one of these two coordinates. Okay, so let's just take this coordinate here. Now we've got an x and a y. Okay, so y, well that's going to be 4. So 4 equals 1x, well that's just going to be 2, plus c. Well, we still don't know what c is, but that's what we're trying to work out. Okay, so 4 equals 2 plus c. If we want to balance this equation, tell you what, let's put the letter on the other side. We're going to have c equals, and we're going to have 4 take away 2. Therefore, c must equal 2. So now we've got all the information we need to describe this straight line. Y equals 1x plus 2. Now, that's a cool little maths trick, but what does it actually mean? What's this telling us? Well, it's basically a way of working out what any coordinate is, as long as you have one of the other details. So let's say we want to know where is the line going to be at 0.5 on the x coordinate. Well, I can work it out. So I want to know, well, what's it going to be on the y coordinate? Well, I put in 5 on the x coordinate, add 2, and I get what the y coordinate is. It's going to be 7. Does that look right? Yes, it does. Okay, so we can work out any other coordinate there using this formula now. If I know that I'm at 0.10 on the y coordinate, I want to know where I am on the x coordinate. So I know that y equals mx plus c. We have the y as being 10, and that's equal to x plus 2. I can then use this equation to work out what the x value is. So x equals 10 take away 2, x must equal 8. Is that correct? If I'm at the y coordinate 10, am I on 8? Well, yes I am. So that's what the equation of a straight line tells us. Our method for finding it out is basically solve the gradient, and then use the gradient, plug in an x and a y value, and then solve the c value there. Let's try it on another couple of examples, working through it a bit quicker. Pause the video as I go if you're struggling to keep up. So, got another one here, steeper gradient this time. So let's solve the gradient first of all. M equals, here's 2, here's 1, here's x and y, here's x and y. So 9 minus 3 divided by 4 minus 2. 9 minus 3 is 6, divided by 2. So m in this case, 6 divided by 2, is 3. The gradient of this straight line is 3. So using that, we can say y equals 3x plus c. We just need to work out c now. What is c in this case? Well, by plugging in an x and a y, we can work that out. So, let's take our x and y from down here, because they're easy numbers to work with. So, y is 3 equals 3 times, what's our x value? 2 plus c. In other words, 3 equals 6 plus c. Right. You know what? I like having my letters on the other side. I don't know about you, but I think it's always much nicer to have the letters on the other side. So c plus 6 equals 3. That makes more sense to me. Right. Now, we just need to work out what c is. So I can get c on its own by subtracting 6. So that means I'm going to need to take away 6 from this side. 3 take away 6. Oh, this is interesting. It gives us a negative number. We get minus 3. Well, why might that be? Well, let's look at the line. We said the c value tells us where it crosses the y-axis, and sure enough, it would cross all the way down here at around minus 3. So the equation of this straight line then has to be y equals 3x, and it says plus c, but actually it's a minus value, so it's going to be minus 3. There is the equation of our straight line. So let's use this to actually try and work something out. So let's say that we were on 0.5 of the x-axis. We want to know where's this going to go next. We can plug it into the formula. Y equals 3x minus 3. We want to know where will we be on the y-axis if we're on point number 5. Well, y equals 3 times 5 minus 3. 3 times 5 is 15 minus 3. So on the y-axis, we would be on 12. Now, all of that can be worked out once we have the equation of the straight line, which is that part there. So we work out the m value, plug in an x and y, and then work out the c value. Let's try just one more example. I'm going to have to do my working a bit all over the place here because I'm a bit pushed for space. So, work out our m value. Y equals, here's 2, here's 1. So it's going to be 8 minus 5. divided by 10 minus 4. So that is 3 divided by 6, or in other words, m is a half. So in this case, our gradient is going up half a box on the y-axis for every one it goes along on the x-axis. So it's going up at a shallow gradient. So we know that y equals a half x plus c. We now need to work out what c is. We're going to do that by plugging in an x and a y value. So y here is 5. X here is 4. So 5 equals, well, a half times 4, that's 2 plus c. So c must equal 5 minus 2. Therefore c equals 3. And right enough, that's exactly what we see here. So our equation for this straight line is y equals a half x plus 3. So there you go, guys. That's how we work out the equation of a straight line. We work out its gradient first of all. Once you've got its gradient, you can work out the c value by plugging in an x and a y for any of the coordinates that you have on the graph. Cheers, guys!